Hi all, welcome to the new series by IMS on Blast from the Past. In today's session, my focus is going to be on algebra. So you can, let's say, pause the video, you can try the question and then you can resume the video over here. So if I look at this particular question, it says that the number of positive integer valued pair x comma y satisfying the equation 4x minus 17y is equals to 1 and x is less than equals to 1000 over here. Now kindly understand one thing, moment suppose we see a single equation in two variable of let's say x and y, the first thought which comes to your mind will be that can we find out let's say a possible pair of answer, and the answer might be a no, because you normally know that if I have two equations and two variable, in that case we can possibly find out a unique value of x and y. But in this particular case, there is no need to find out the unique possible value of x and y. We need to find out the possible number of possible pair. So answer basically is going to give you a finite number of answers. So what are the key things? So apart from the given equation 4x minus 17y is equals to 1, they have also given you another condition which one can say is x less than equals to 1000. At the same time, they have also imposed the condition on x and y both to be positive integer. So this condition in a way act as one can say, you can say your second equation to give you a finite number of outcomes over here. So let's see what we can do. So normally the starting point in this particular case happens to be, we try to find out one small possible solution, let's say for x and y, and then we are going to generate some sort of pattern. So over here if you look at 4x minus 17y is equals to 1. So 4x will be equals to 17y plus 1 over here. Now, if I look at the left hand side happens to be a multiple of 4 because x and y are positive integer. So the term 4 into x will be a multiple of 4. So what I want is, I want to look at some positive integer value of y such that the term 17y plus 1 becomes a multiple of 4 over here. So one can do hit and trial, they can put let's say y equals to 1. If I put y equals to 1, the term 17y plus 1 will become nothing but equals to a 18. Then if I put let's say y is equals to 2, it will become 17 into 2 plus 1 giving you a 35, not a multiple of 4 so far. If I put y is equals to 3, in that particular case one can say that the value of 17y plus 1 become equals to a 52, which happens to be a multiple of 4 over here. So one can find a possible solution for y equal to 3, my term 17y plus 1 become 52, which makes a value of x to be equals to a 13. So if I write down, we have got one possible solution as one can say x is 13 and the corresponding value of y become equals to a 3 over here. Now what happens once I find out one possible solution? The answer would be, we have to look for some sort of pattern, and the pattern basically would be, one can say if the value of x is increased by 17, the value of y will increase by the number 4 over here. So one can now again try it out, that in case suppose I increase the value of y by 4, which makes y equal to 7, the corresponding value of x must increase by a 17 over here. So in this particular case, the next possible solution happens to be 30, 7. We can just see also 30 into 4 is 120 minus 17y term will become 119, and the difference happens to be equals to a 1 over here. Now you can also think about this same thing with the help of the slope concept, those of you are confused, because moment suppose I say y is equals to mx plus c, because a linear equation of two variable I can write in the form of y equal to mx plus c, because all linear equations of two variable represent nothing but one can say a straight line. So here this term m denotes the slope over here. So in this particular case, if you write y in terms of x, for example, you can say 17y would be equals to a 4x minus 1, y would be equals to 4 upon 17 times of x minus 1 upon 17. So slope happens to be equals to 4 over 17. What does this mean? Since the slope is positive, this would mean both x and y will increase or both x and y will decrease. This basically means if I increase the value of x by 1 unit, in that particular case the value of y will go up by 4 upon 17 units. Or one can say, if you increase the value of x by 17, in that case the value of y will increase by 4. Or we can say, if the value of x is reduced by 17, in that particular case the value of y will come down by 4 over here. So both are basically going into the same direction. So now, as I told you, I got 13 and 3 as one solution. Then I got 13 and 7. The next possible solution happens to be nothing but one can say 11. And this part basically become equals to a 47. So if you see, can I go backwards? Because you can say if I reduce the value of x by 17, in that particular case x become equals to a minus 4 and the value of y will be reduced by 4, giving you a minus 1 over here. But understand, since I have told you x and y are positive integer, we can't take any of these solutions. So first possible solution happens to be 13, 3, 37, 47, 11 and so on. And now if you clearly focus, let's say, on the series of y, which is 3, 7, 11, 15 and so on, one can say since we have a constant difference, it simply means we are following a AP series. Now since they have given you condition on x, my focus basically has to be on the series formed for the value of x. So I can see 13 being one such term, then a 30, then a 47 and so on. It's a AP whose first term one can say is 13, and the common difference in this particular case happens to be nothing but a 17 over here. So now what we want is, we want the last term of this sequence to be less than or equal to 1000. So we can write down the general term of a AP is given by the formula a plus n minus 1 times of d. A is the first term, d is the common difference, so one get 13 plus n minus 1 into 17, and this part on simplification will give you 17n minus 4. So we get our first value of 13 by n equals to 1. I got the next value of, let's say, x, which is 30, by putting n equals to 2 over here and so on like this. So what you want is, for this particular sequence, I want the nth term, which is 17n minus 4, must be less than equals to 1000. So the term 17n must be less than equals to 1004 over here, 1004. Now clearly one knows 17 times of 60 is equals to 1020. In that particular case, I can say in this particular case that the value of n will be nothing but less than equal to 17 times of 5 will be 85, then I get the number 154, and one can say I can go 9 times. So 17 times of 9 is 153, so 59 point something, which means my largest possible value of n is 59, and the value of n was starting from the number 1. So n can take the value from 1 till 59, and hence one can say we have 59 possible pairs of x comma y, where both the numbers are positive integer. At the same time, we also meet the condition that x also happens to be less than equal to 1000, which means option number 1 is the required answer for this particular question. The next sum which we have is a nice question, and the sum goes like this. M is the smallest positive integer such that for any integer n, where n is more than equals to m, the quantity n cube minus 7n square plus 11n minus 5 is positive. What is the value of m over here? So now in this particular case, understand first of all, if I want n to be, let's say, more than equal to some number 8, let's say. So when I say n is more than equals to 8, in that particular case, what can we infer? We say in simple word that the minimum value of n happens to be nothing but equals to 8 over here. So when I say n is more than equals to m, the minimum value of n happens to be nothing but m, and my task is also to find out the value of m, where m is the smallest possible positive integer. So in this particular case, we will look at the inequality. I want the expression n cube minus 7n square plus 11n minus 5 to be positive, so more than 0. Now since we have a cubic expression over here, we will try to factorize it, and using some hit and trial method. We will look at two methods to factorize this particular part. One would be using the normal hit and trial approach. So first of all, if I tell you in this particular case, if I take my function f of n as n cube minus 7n square plus 11n minus 5. So let's say what we would normally do is we put n equals to 1 and we see whether we get the function to be equals to 0 or not. If not, we try with minus 1, then 2, minus 2, 3 and so on. So n equals to 1, if you look at, will give you f of 1 to be equals to 1 cube minus 7 times of 1 square plus 11 into 1 minus 5. So we get 1 minus 7 plus 11 minus 5, and this thing does become equal to 0. What does that mean? That simply means that if n equals to 1 is a possible solution, so n minus 1 has to be one of the factor. So now we know for this cubic expression, n minus 1 definitely happens to be one of the factor. At this particular point of time as well, one can try out synthetic division or you can try out the long division method as well. So we can write down this part, n cube minus 7n square plus 11n minus 5, and suppose I will, let's say, try to divide this thing by n minus 1. Now what will you multiply in the term n to reach n cube, and the simple answer happens to be n square. So I will multiply the term, let's say, n minus 1 with n square, and that will give you n cube minus n square. Let's subtract. You get now minus 6n square plus 11n minus 5. Now what will you multiply in n to reach the number minus 6n square, and the simple answer will be multiply by minus 6n. So I get minus 6n square plus a 6n, and again subtract, and what do one get? 5n minus 5. Now what will you multiply in the number, let's say, n to get the number 5n? We simply multiply by a 5. So one get 5n minus 5, which means if I divide the cubic polynomial n cube minus 7n square plus 11n minus 5 by the term n minus 1, we get this as the other factor, n square minus 6n plus 5. So now what one can say is that the term n cube minus 7n square plus 11n minus 5 I can write as n minus 1 times of n square minus 6n plus 5. Now this simply become a quadratic, and we know the method of middle term split to write down this particular part as a possible n minus 1 into n minus 5, because 1 into 5 is 5 and 1 plus 5 happens to be equal to a 6. That means the given polynomial I can write in the form of n minus 1 whole square into n minus 5 over here. So let's rewrite this particular part in simplified form as n minus 1 whole square. So n minus 1 whole square times of n minus 5 to be positive. Now understand the term n minus 1 whole square happens to be always non-negative. So this part one can say is always going to be positive. It can be equal to 0 also, but since my concentration happens to be on more than 0, I will say this term is always positive. It can never be negative. So now, which means that the term n minus 5 need to be positive. So if I say n minus 5 need to be positive, this means that the value of n need to be more than 5. And what do you think is the first integer value which is more than 5? And the simple answer would be nothing but equal to a 6. So one can say n has to be more than equals to a 6. If that is the case, the smallest possible value of n will be nothing but equals to a 6. And if I compare this, one can say my value of m need to be equal to 6 over here. And for that, one can choose to mark option number 4 as the answer for this particular question. If I look at another way to solve this particular question, again with the help of hit and trial, what we can also do is, we know this property that if I have ax cube plus a bx square plus a cx plus d equals to 0, and if I say my roots are alpha, beta, gamma, then we know this alpha plus beta plus gamma must be equals to a minus of b by a. The sum of the product of the roots taken 2 at a time, that is alpha beta plus alpha gamma plus a beta gamma, should be equals to a c over a. And finally, the product alpha beta gamma should be equals to a minus of d over a. So in this particular case, if I compare this part, first of all, you can say n cube minus 7n square plus 11n minus 5 equals to 0. And suppose if I want to find out the value of n which makes it equals to 0, so one can say here that alpha plus beta plus gamma must be equals to the number 7, and similarly alpha beta plus beta gamma plus alpha gamma must be equals to 11. At the same time, the term alpha into beta into gamma is equals to 5. If I think that the values of alpha, beta, gamma are nice number, we can go for some hit and trial. And if you look at the number 5, I can possibly split the number 5 as 1, 1 and 5, 1, 1 and 5. Now in that particular case, you can notice that alpha plus beta plus gamma is also equal to 7, 1 plus 5 happen to be equal to 7. But you have to also ensure that this condition is also met. So one can check that 1 into 1 plus 1 into 5 plus 1 into 5 is also equals to the number 11 over here, which means that the roots are nothing but 1, 1 and 5. In that particular case, the same thing I can write in the form of n minus 1 whole square into n minus 5 more than 0, and then we can use the same technique. Since n minus 1 whole square happens to be always positive, that means the term n minus 5 need to be more than 0, n need to be more than 5, so n has to be minimum equals to a 6 over here. Hence option number 4 is the answer for this particular question. In the next sum, they have given if x square plus 5y square plus z square is equals to 2 into y times of 2x plus z, then which of the following statement is or are always true over here? Now what we can do in this particular case is first of all try to bring everything on the left hand side, and what do we get? X square plus a 5y square plus a z square is equals to, first of all it is 4xy plus a 2yz. If I bring the term 4xy plus 2yz on the left hand side, one will get this minus 4xy minus 2yz equals to a 0. Now at this particular point, you should think about the property that if you have something like a plus b whole square, that thing is equals to a square plus a b square plus a 2ab. And if I have a minus b whole square, it is a square plus b square minus of 2ab term. So if you look at the 2ab term part in this particular case, in both the cases we have the term y to be common, which means somewhere we have to split this particular number 5y square. So now what I will do is first of all look at the term a square minus 2ab, and accordingly I will balance the term b square over here. So suppose if I take this term x square minus 4xy first of all together, then the term let's say z square minus 2yz term together, and we have additional 4y square equals to 0. Now at this particular point I can see now x square I can write as x whole square minus 2 into x. Now what will you multiply in the term 2x to reach the number 4xy? And the answer is I need 2y term. If I now compare this part with the a square minus 2ab, your b term happens to be 2y. That means the term b square must be equals to 2y whole square, which happens to be 4y square. And please note the given term of y square was nothing but 5y square over here. Then similarly, if I write down the term z square as z whole square minus 2 into z, what will you multiply in the term 2z to reach the number 2zy or 2yz? Just multiply it by y. So now again a square minus 2ab, the term b is y here, the term b square becomes y square. And understand now in this particular case, if I focus on my term 5y square, it actually was split into 4y square and y square. And what happens now, if I look at my first three terms together, this part become x minus 2y whole square. The second bracketed term I can write as z minus y whole square equal to 0. Now, if I have sum of the two square quantity to be equals to 0, when can that happen? This can only happen when each square term are each individually equals to 0. Why? A square term can never become negative. So in this particular case, one can say the term x minus 2y has to be 0. At the same time, the term z minus y also need to be equals to 0. So one get x equals to 2y and we get z equals to y. These are my condition. So let's see, the A says x equals to 2y is always true. X equals to 2z. Now understand, since x equals to 2y and let's say z is equals to y, so one can say x equals to 2z is always true as well. So A is true, B is also true. At this particular moment one can say option number 1 is out, option number 2 also is out. The third one says 2x equal to z, and this is not true always. So only A and B, so one can choose to mark option number 3 over here. In the next sum, it says that if both A and B belong to the set 1, 2, 3, 4, then the number of equation of the form ax square plus bx plus 1 equal to 0 having real root. Now understand, what we know is that if I have ax square plus bx plus c equal to 0, and if I say roots are real, in that particular case my condition happens to be nothing but the discriminant, which happens to be b square minus 4ac term, need to be more than equal to 0. So discriminant need to be more than equal to 0, which is b square minus 4ac term need to be more than equals to 0. Now in this particular case, if I compare the given quadratic with the standard one can say we have a as a, b as b, and the value of c is given to you as 1. So one can now say b square minus 4a must be more than equal to 0, or my condition become b square has to be more than equals to a 4a. Now understand, the value of a can only be 1, 2, 3, 4. At the same time, b can also take the value among 1, 2, 3, 4 over here. So what I will do is, let's put the value of a equals to 1. If a is equals to 1, we are getting b square to be more than equals to 4. And over here, the least value of b which will satisfy happens to be nothing but 2 as integer. So here b can take the value, one can say 2, 3 or 4. Similarly, if I possibly take a equals to 2, then the term 4 into a will become 8. So I want now b square to be more than equals to 8. The first perfect square more than equal to 8 happens to be a 9. So one can say the value of b which will work here is 3 or 4. Then I can take the value of a to be equals to 3. In that case, 4a will become equals to 12. More than equals to 12, the first known square number happens to be the number 16, and that is for b equal to 4. 4 square is 16. So b square more than equal to 12. So acceptable value of b happens to be only a 4. And finally, if I put a equals to 4 also, the term 4 into a will become 16. Now I want b square to be more than equal to 16. The only value of b satisfying this condition happens to be nothing but b equals to a 4. If you count this number of cases, we have found 3 cases for a equal to 1, then 2 cases for a equals to 2, and then 1 case each for a equal to 3 and a equals to 4. If you add this total, so one get 3 plus 2 5, 5 plus 2 become equal to 7, and hence option number 2 is the required answer for this particular question. The next sum is a nice one. Here the question says that a test has 50 questions. A student score 1 mark for a correct answer, minus 1/3 for a wrong answer, and minus 1/6 for not attempting the question. And now the statement says if the net score of a student happens to be 32, in that case the number of questions answered wrongly by that student cannot be less than. Now many people, let's say, will get fumbled by this particular statement, the number of questions answered wrongly by that person cannot be less than. For example, suppose if I replace the term number of questions answered wrongly by, let's say, the term y. And if I say y cannot be less than something, for example, if I say y cannot be less than some number, let's say 10 for example. Y cannot be less than some number 10. What does that mean? Y cannot be less than 10. It can be equal to 10 or more than equals to 10. So y can be more than equals to 10. In other words, my task, if you look at y is more than equals to 10, my task basically is to find out the minimum value of y. I hope it is clear. If I say y cannot be less than something, that means y has to be minimum equal to that particular quantity. And I took some random example also over here. So let's say in this particular case, since I have told you every question can be classified as where you can get it right, wrong, or you choose to leave it. So suppose if I say for every correct answer, let's say we have made x number of correct answers. The number of, let's say, wrong answer which I want to minimize is suppose y, and suppose we left certain number of questions which basically are z over here. So I take three variable x, y and z, and the first thing, know the total of this three number, the number which I got it right, the one I got it wrong, and the one which I left it, has to give you a sum of nothing but a 50 over here. So my first equation become, one can say, x plus y plus z equals to a 50. The next equation, if you look at, is about the score of 32. Now understand one thing, for every correct answer we are getting a plus 1. So if I made x number of right responses, in that particular case my marks would be nothing but 1 into x. Now if I suppose have made y number of mistake, and since I am going to lose 1/3 for every wrong response, this particular part becomes minus 1/3 of y, or one can say minus y by 3 is my loss. And for the one which I left, I also lose 1/6 for every question. So if I made, let's say, z number of question which I left it out, I will lose a minus z by 6. And this will give me my net score, which must be equals to a 32 over here. Now, if I focus on my second equation, I can see some sort of fraction. To simplify the second equation, what I can possibly do is, because I can see number like 3 and 6 in denominator, I will choose to multiply my second equation by, let's say, 6. And if I do that, I will get 6x minus 2y minus z, and this should be equal to 32 into 6 become equals to a 192. Now please note, in this particular case, task is to minimize the value of, let's say, y over here. Now clearly if I call this as equation number 1, and suppose equation number 2 is 6x minus 2y minus z as 192, I will first of all try to eliminate one variable which I can clearly see is going to be z, because I can see a plus z and a minus z. In that particular case, we will choose to add the two equations over here. If I choose to add the two equations, I will get nothing but x plus 6x becomes 7x plus y, and minus 2y will give me nothing but a summation of minus y. Z will get cancelled out, and this should be equals to a 50 plus 192, giving you a 242. Now since I want to find out the least possible value of y, I will write down y in terms of x. So y will be equals to, one can say, 7 times of x minus 242. Now understand one thing, that what is the nature of x, y, z? They represent nothing but the number of questions which are right, wrong, or you chose to left it. So this quantity x, y, z by default has to be a whole number. It can't be a negative quantity, it can't be in decimal as well. So clearly, since y also need to be a non-negative integer in the worst possible case, understand what I want is 7 times of x minus 242 need to be, one can say, more than equal to 0. So first thing would be, since I want to minimize the value of y, I want to look at a multiple of, let's say, 7, because the number 7 into x need to be more than or equal to the number 242. The smallest possible number which is a multiple of 7 which is more than 242 is, because understand 7 into 30 happens to be 210. Then you will get 217 to be a multiple of 7, then a 224, 231, 238 which is less than 242, but the number 245 which is nothing but 7 times of 35 happens to be nothing but a multiple of 7 and also more than the number 242 over here. So lowest multiple of 7 more than 242 happens to be nothing but 245. So the minimum value of y will be nothing but, this is 7 into 35 which is 245 minus 242, giving you a 3 over here, and the smallest possible value of y is 3, and hence one can choose to mark option number 3 as the answer for this particular question. Let's look at one more way in case people wanted to eliminate the other variable, let's say x in this particular case. So I want to make the coefficient of x same. So what I can do is I can modify my first equation by multiplying throughout by the number 6, giving you 6x plus 6y plus 6z equals to, one can say, a 300. And then suppose if I do equation 1 minus equation 2, I will get x getting cancelled out. I will get 8y plus 7z to be equals to nothing but 108 over here. And in this particular case, 7z should be equals to, one can say, 108 minus 8y. So again, someone can put the smallest possible value of y. If I look at the option, I can try with option number 3 saying y equal to 3. If I put y equal to 3, the term 108 minus 8y, so 108 minus for y equal to 3 will give you 24. This part become equals to, one can say, 84, and is 84 happens to be a multiple of z, since x, y, z by default are going to be nearly a whole number. So z will become equals to a 12 over here. So in this particular case, one can notice that your smallest possible value of y equal to 3 perfectly suits, and hence one can choose to mark option number 3 as the answer for this particular question. In the next sum, again a very standard one, the question says the total number of integer pairs x comma y. Again look at the word integer pair. They have not told whole number or whatever. They have told the term integer, which can mean positive as well as negative, satisfying the equation x plus y equal to xy. Now in this particular case, normal tendency will be to write down one variable in terms of other. That is one approach. Another basically will be to help with the help of, one can say, factorization. So over here, what I can do is, suppose if I say, let's take the term y on one side. So x would be equal to xy minus y. Now if I look at this particular part, I can take y common from the right hand side. So x would be equals to y into x minus 1. And then one can write y would be equals to x over x minus 1. This is what we have at this particular moment. Now understand what we can do is, since y is equal to x over x minus 1, at this particular point of time, normally I want to represent my denominator in, let's say, terms of a single variable. So one can write this as x minus 1 to be equals to k as well. If I take x minus 1 to be equal to k, then the value of x will become equal to k plus 1. So now I will write everything in terms of k. So the numerator x I will write as k plus 1, and denominator x minus 1 was equals to k. And then one can say y will become equals to k over k is 1 plus 1 over k. And now if I want the value of, let's say, y to be integer, in that particular case the number 1 already happens to be integer. So I want to choose the value of k such that the term 1 over k also becomes an integer. And what value of k you should choose? I want to choose the value of k either positive or negative such that it can divide the number 1. And the only thing would be, one can say, k equals to a 1 or a minus 1 over here. So please note, I told you k will be equals to 1 or a minus 1, and let's see whether we have a problem if I put k equals to 1 or a minus 1 as well. So if I put k is equals to 1, so for k is equals to 1, the value of y will become 1 plus 1, which is 2. And what do you think will happen if I put k equals to 1, the value of x, because x is k plus 1, x will become equals to a 2. And do I have any problem with this x2 and y2? You can see x plus y will become 4, and the term x into y also become 4 because 2 into 2 happens to be a 4. It's perfectly fine. Now what about if I put k equals to minus 1? If I put k equals to minus 1, in that case the value of y will become equal to 0, and the value of, let's say, x will also going to become equal to 0. And do we have any problem whatsoever by putting x equal to 0 and y equal to 0? Answer is again no. In the original equation, 0 plus 0 is 0. And 0 into 0 also is 0. It's perfectly fine because they also happens to be an integer value. So we have found out that we got one possible pair of x and y for k equal to 1, another pair of x and y for k equals to minus 1. Hence, my answer over here will be nothing but option number 3. If I look at one more way to solve this particular question, here the balancing thing will be required. So I will bring everything on left hand side. X plus y minus xy is equals to a 0. Now I will try to take something as a factor. So let's say if I take the term y minus xy, I can take y common and we get 1 minus x as one of the factor. Now what I want is, suppose if I want a 1 minus x to be a factor. In that particular case, please note that we had the term x and now we have a minus x. So what will you multiply over here so that on multiplication the term minus x will become equals to a plus x. So one can say you multiply by a minus 1. If I do that, the only thing which is not balanced right now is the constant term, because the constant term, if you look at now on the left hand side, happens to be a minus 1, because if you multiply you get minus 1 plus x plus y minus xy. All these three are balanced, but the term minus 1 happens to be extra on the left hand side. To balance it out, one have to put a equal term on the right hand side. Now things are pretty much balanced. And what I can take common now is, I can take the term 1 minus x common, and this part will be minus 1 plus y is same as saying y minus 1 equal to a minus 1. If I multiply by negative 1, so this RHS become equal to 1, and I can rewrite my first bracketed term as x minus 1. So I get x minus 1 into y minus 1 equals to a 1. Now product of two numbers, two integer numbers, since x and y are integer, so term x minus 1 and y minus 1 also become integer. So the only way we can achieve this particular part will be when each of them are equals to 1 into 1 or a possible minus 1 into a minus 1. So in this particular case, if you take the first scenario, you will find out the value of x to be 2 and y to be 2. In the second case, x to be 0 and y to be equal to 0. Please note, task is not to find out the value of x and y over here. Since I can represent 1 as 1 into 1 or minus 1 into 1, one can say we are going to get two values of x and y as a pair. Hence option number 3 is the answer. In the next sum, interesting one, it says that a quadratic function f of x attains a maximum, this word is also important, maximum of 3 at x equals to 1. They also gave you the value of the function at x equal to 0 happens to be equals to a 1. What is the value of the function at x equals to a 10 over here? And they gave you the options also. Let's look at one of the normal way to solve this particular question. So normally we take our function as quadratic. We can take them in the form of ax square plus bx plus c equals over here. Now, since the function is maximum, this tells us that the coefficient of x square, or in this particular case, a, would be negative. Because the graph, when a is negative, the graph basically becomes downward opening parabola, giving you max value. Whenever a is positive, the graph basically happens to be a downward opening parabola. One can say you get a minimum value over here. So since they have told you maximum, that is why I am saying the value of a need to be negative. Now what we also know is that the minimum value, so the minimum or the maximum value of the function, so maximum value of f of x, we know the formula, one can use derivative also to solve this, or I am saying the max value of the function happens to be nothing but a 4ac minus b square upon 4a always. This people also know as minus of delta divided by 4a, and this happens for x equals to a minus of b by 2a. So this is the value at which the function becomes minimum or maximum, and the function value at that point always comes out to be equals to 4ac minus b square divided by 4a. This is one of the approaches. So understand now what we have given is the value of x at which the function become maximum happens to be equals to 1. So I will do this, minus b by 2a is equals to 1. So from this I can find out b will be equals to a negative 2a. So I found out one variable in terms of other. So we got b in terms of a. Then what I can do is I can take the help of this particular part, the maximum value of 3. What does 3 is equal to? 3 is equal to nothing but one can say 4ac minus b square upon 4a. So 4ac minus b square upon 4a is equals to a 3. Now you cross multiply. If I cross multiply, one will get 4ac minus b square to be equals to a 12a. Now also understand one thing over here, that since a is going to be negative and they have given you the function value at x equal to 0 is 1. Now if someone put x equal to 0, f of 0 will become equal to a into 0 square plus b into 0 plus a c. That means f of 0 happens to be nothing but equal to c. So c is known to you as the number 1 over here. So what happens now? We can put c is equals to 1 and we get 4a minus b square is equals to a 12a, and from this I will get minus b squared, or b square term rather, will be equals to a minus of 8 into a. So now since b is equals to minus 2a, the term b square happens to be equals to 4a square. So I can now say 4a square is equals to a minus of 8a. So since a is negative, I can cancel one of the a from both sides, and one will find out the value of a become equals to a minus 2. And if the value of a become equals to minus 2, we can find out the value of b. So the term b, so c is 1 and the value of b will be equals to minus 2a, giving you a 4. So we found out a as minus 2, the value of b as 4 and the value of c as 1. And once this is done, we can say my required function I can write as minus 2x square plus 4x plus 1. And since they say find out the value of, let's say, f of 10, so the value of f of 10 will be nothing but f of 10 will be equals to minus 2 times of 10 square plus a 4 times of 10 plus a 1 minus of 200 plus 40 plus 1, and this thing become minus of 159. And hence one can say option number 2 is the answer for this particular question. But the earlier method was not very easy. Let's look at an innovative method to solve this particular question. So kindly understand one thing, that in case suppose I tell you that a function happens to be in the form of this x minus 1 whole square plus a 5, then one can say that this function is going to be minimum at x equals to 1 and that function value happens to be equals to 5. Now if I say this is x minus 1 whole square plus 10, then again one can say the function will be minimum at x equals to 1, giving you the least value as 5, because a square quantity can never be negative. What about if I make it something like f of x equals to 3 times of x minus 1 whole square plus 10, again one can say the function will be minimum at x equals to 1 and the value will be equals to 10 over here. So now similarly, if someone tell you my function is going to be in the form of this, f of x is equals to 5 minus x square, what can be said? One can say the function will be max equals to 5 at x equals to 0. If I make it, let's say, 5 minus x minus 3 whole square, then again one can say function has to be nothing but 5 minus a non-negative quantity. So a max value of 5 at x equals to 3 over here. Then again if I possibly put a maybe 2 here, so again one can say function will become max equals to 5 at x equals to 3 again. So in this particular context, since they have told you maximum of 3 at x equals to 1, should I say my function should be somewhat like this, a max value of 3 whenever x was equals to a 1. So it must be equal to 3 minus something into x minus 1 whole square. So here I can say the function will be max equal to 3 for x equals to 1. Even if I put a 2 here, then also one can say same thing, the function will be max equal to 3 at x equals to 1. So one can say I don't know this. I don't know what is getting multiplied with the term, one can say x minus 1 whole square. So now in this particular context, what we can do is to find out the value of a, we have to take the help of this result. X equal to 0, the function happens to be a 1. If I put x equal to 0, so I get f of 0 to be 3 minus a. This term will become minus 1 square, which is simply a 3 minus a, and this f of 0 is given to you as 1. So from there a will become equals to a 2. So understand now my function f of x become nothing but a 3 minus 2 times of x minus 1 whole square. And since they want the value of f of 10, so f of 10 would be equals to 3 minus 2 times of 10 minus 1 whole square. 10 minus 1 happens to be a 9, this part becomes a 9, 9 square becomes a 81, so we get 3 minus this part become 162, we get 159, negative of 159, hence we can choose to mark option number 2 as the answer for this particular question. In the next sum, it says that how many pairs of positive integer m comma n satisfy the equation 1 over m plus 4 over n equals to 1 over 12, where n happens to be an odd integer less than 60. So in this particular case, I will let's say try to find out m in terms of n, and then we can use this particular condition given to us. So one can say 1 over m should be equals to 1 over 12 minus 4 over n. Then if I look at the RHS part, I can take a LCM of 12n and we get nothing but one can say n minus 48 in the numerator of RHS. Then if I cross multiply, I can say the value of m should be equals to 12n over n minus 48. So task basically was to represent one variable in terms of other. Now again, one can write down the same technique, take the denominator some variable, let's say k. So if I assume suppose n minus 48 to be some variable k, then n will be equals to one can say 48 plus k or k plus 48, whatever you want to call it. So write down now m is equals to 12 times of the value of n is 48 plus k, or one can say k plus 48 divide by k. This will become 12k plus 12 into 48 become 480 plus one can say 96, giving you a 576 divide by k, and this thing is equals to 12 plus 576 divide by k. Now please notice the nature of m and n in this particular case happens to be positive integer. So since now m is equals to 12 plus 576 over k, what I want is, if I want m to be a positive integer, this particular term 576 upon k need to be an integer quantity, or one can say actually a positive integer quantity. So here one can say the value of k need to be, one can say, a number which is going to divide the number 576. So one can say k need to be something which has to be a factor of the number 576. Please note m or n should not become negative. Both m and n need to be a positive integer. So now please note k is going to be a factor of the number 576. And what can you say, since n is given to you as an odd number, then what can you say about the term n minus 48? It is also going to be odd because odd minus even happens to be odd. So one can say here k is also going to be an odd number. Now since they have told you n is an odd integer less than 60, so if I say n is less than 60, that basically means the term 48 plus k also need to be less than 60. In other words, one can say k has to be less than 12. And please note k is an odd number and k is less than 12. The acceptable value of k right now can be, one can say, among 1, 3, 5, 7, 9 and 11. And I want to check in this particular case whether k equal to 1 can divide 576. The answer is yes, because 1 is a factor of 576. This number is also known to us as 24 square. 24 means 2 cube into 3. So this particular number is 64 times of 9, or one can say 2 power 6 into a 3 square. K equal to 3 is a factor. K equal to 5? No. 7? No. 9? Yes, because 3 square happens to be a factor. 11? No. So one can say for k equal to 1, 3 and 9, we can find out the corresponding value of m and n as well. In this particular case, please don't say we can put k equals to minus 1, minus 3, minus 9. Why? Because if you put k as minus 1, the value of m will become negative. Even let's say for k equal to minus 3, the value of m will become negative and so on. So in this particular case, we have 3 such value of k, and hence we have, one can say, 3 such solution. So one can choose to mark option number 5 as the answer for this particular question. In this sum, it is given that if the roots of the equation x cube minus ax square plus bx minus c equal to 0 are 3 consecutive integers, then what is the smallest possible value of b? Now what I can do is I can take my roots as alpha, alpha plus 1, alpha plus 2, but since they are consecutive, they also follow a AP which are one after the other. I can also take them as alpha minus 1, alpha and alpha plus 1. Now we can use this particular property that sum of the roots, the sum of the roots in this particular case will be nothing but equals to a, because from that ax cube plus bx square plus cx plus d equal to 0, sum is equals to minus b by a, where b is the coefficient of x square and a is the coefficient of x cube. Then similarly, sum of the product of the roots taken two at a time is equals to a c by a, where c is the coefficient of x and a is the coefficient of x cube. So this will become equals to a simply b. And finally, the product of the roots is equals to, one can say, a minus of d by a, and that is going to be equals to, in this particular case, a c simply. Now since my concentration is going to be on the value of b, so let's remove this, and suppose if I write down this part, so alpha minus 1 into alpha plus alpha into alpha plus 1 plus alpha minus 1 into alpha plus 1 is equals to a b. So in this particular case, what we can do is this part become alpha square minus alpha plus alpha square plus alpha plus alpha square minus 1 is equals to a b. And now one can notice minus alpha plus alpha becomes cancelled out. We get the expression b as 3 into alpha square minus 1 over here. And notice one simple thing in this particular case, my objective is to minimize the value of b. Now b is equal to 3 into a square quantity minus 1. If I want to minimize the value of b, then the term 3 into alpha square need to be minimum. That means the minimum value of alpha should be taken as 0. So my 3 consecutive integer which makes the value of b minimum happens to be nothing but, one can say, minus 1, 0 and 1, and that basically will give you the value of b as 3 into 0 square minus 1, giving you negative 1. Hence one can choose to mark option number 2 as the answer for this particular question. If you see a more structured approach over here, task is to minimize the value of b, where b will be nothing but, one can say, sum of the product of the roots taken two at a time. So like b is equals to alpha into beta, beta into gamma plus alpha into gamma. Now since the roots are 3 consecutive integers, so that means alpha, beta, gamma also happens to be integer. So alpha into beta will be integer, beta into gamma will be integer. So all these 3 terms are also integer, which means the value of b will always be integer. And that tells us it cannot be option number 1, can't be option number 5 right now. Now understand this thing that we want to minimize the value of b. If I take all my 3 roots are positive integer, in that case alpha into beta will become positive, beta into gamma is also going to be positive, alpha into gamma is also going to be a positive number. In that case the required result will definitely going to become positive as well. Now what about if I say all my 3 roots are negative integer? If the integers are negative, then alpha into beta will become again positive, because negative into negative is positive. So even if I take all the 3 roots as negative, alpha into beta will be positive, beta into gamma will be positive, alpha into gamma will be positive, and hence the value of b again become positive over here. So now since I want to minimize, and what do you think will be nothing but your minimum possible value over here? So one can say 1 plus 1 plus 1 become equal to 3 or more. Even I can't take them to be equal because they are nothing but consecutive integers. So if I can't take them all positive or all negative to minimize the value of b, can I say what we can do is we can assume one of them to be 0. So if I assume one of them to be 0, so one can possibly think about, okay, let me then possibly try out the number 0, 1, 2, or 0 being the largest, then -2, -1 and 0, and 0 can be the middle one where -1 and +1. Understand, in this particular case, if I do alpha into beta, I get 0. If I do alpha into gamma also, I get 0, but the term beta into gamma will become positive. So b become equals to 2. In this case also similarly, -2 into -1 will give you a 2. But understand now, if I do -1 into 0, I get 0. 0 into 1, 0. And when I multiply -1 and 1, that will become equals to a -1. The smallest possible value of b in this particular case happens to be a -1, and hence one can choose to mark option number 2 over here. In the next sum they have given, if x into x minus 3 is equals to -1, then find the value of x cube into x cube minus 18. Now what we can do in this case is, suppose if I given thing, if I multiply left hand side, I get x square minus 3x is equals to a -1. And then suppose if I divide by x throughout, please note that since I know that x is not equal to 0, why? If x become equal to 0, LHS becomes 0, RHS happens to be -1, x equal to 0 is not a root, and hence I can divide by x here, giving you x minus 3 is equals to -1 by x. And if I simplify this, one can say x plus 1 over x should be equals to a 3 is what we have at the moment. Now what we can do next is, if I know x plus 1 upon x equal to 3, and somewhere we have to find out x cube into x power 3 minus 18, I can possibly try to find out the value of, one can say, x cube plus 1 by x cube. And for this we will take the help of some known algebraic formula. A cube plus b cube is equals to a plus b whole cube minus 3ab into a plus b. So x plus 1 over x cube minus 3 into x into 1 by x times of x plus 1 over x. And what we know is the term x plus 1 upon x is known to us as the number 3. So 3 cube becomes 27 minus 3 times of 3. This part becomes 27 minus 9, giving you a 18. So what do we have over here? We have the term, if I simplify, x cube plus 1 upon x cube equals to 18. If I multiply now, we get x power 6 plus 1 is equals to 18x cube. So if I bring this term on the left hand side and one RHS side, I get x power 6 minus 18x cube is equals to a -1. And if I take x cube common, I get x cube minus 18 inside the bracket equals to a -1, which makes our answer as option number C over here. The other thing which I can do in this particular case is, if I open, first of all, I get x square minus 3x is equals to a -1. Now since I want the value of x cube into x cube minus 18, which on opening will become x power 6 minus 18x cube. So the obvious thing in this particular case would be to cube over here, because if I cube the term x square, I get nothing but x power 6. If I cube both sides, x square minus 3x whole cube will be equals to a -1 whole cube. And understand now, the term a minus b whole cube is nothing but a cube minus b cube minus 3ab times of a minus b. So I can write x square whole cube minus 3x whole cube minus 3ab, 3 into x square into a 3x times of a minus b, which is x square minus 3x. And -1 whole cube is also equals to a -1. Now if I pay attention, the term x square whole cube become x power 6 minus the term 3x whole cube will become 27x cube. This part right now will become nothing but minus 9x cube. And please pay attention, the value of the term x square minus 3x was known to us as -1. If I simplify this, x power 6 minus 27x cube, this part become plus 9x cube is equals to a -1. So we get x power 6 minus 18x cube equal to a -1 take x cube common, we get x cube into x cube minus 18, which I am supposed to calculate is equals to a -1, and hence we can choose to mark option number 3 over here.